Today we work on exercise 11 and exercise 20 on section 9.2. So this is the problem in exercise number 11. It says, can you verify whether it converges or diverges? So here is a sequence, a series that looks like that, and the terms are all like that. And if you're not familiar, you just substitute n equals to 1, and then when equals to 2, n equals to 3, so on and so forth. You probably, suspect that the numbers get bigger and bigger and ever bigger. So you probably suspect that this is diverging. But if you do not suspect and you have a stronger reason, you can say, I think I know what this is. This is a geometric series. Once you realize that it's a geometric series, there are two things you have to tell me. Firstly, what is the first term? And first term is very easy. The first term is the first thing you saw on here. And then what is the common ratio? Whenever you wrote down a geometric series, I'm going to assume that A means first term and R means common ratio. But if you don't write geometric series, then A and R means nothing. They don't mean anything. But now I've written the word geometric series. A means first term, R means common ratio. Now we know that the common ratio itself will determine whether it's converging or diverging. But since the common ratio is numerically big, we know that this series is diverging. Number 20 is talking about this kind of series. Well, if you write the first few terms, you will very quickly realize that this is also geometric. And it's hard to tell whether it's converging or diverging because you see it is negative and then you add a positive term and then you subtract another term and then you add another term. And so you do this adding and subtracting. You're not very sure in the end you come up with something or not. So the best way to do it would be to recognize that this is also another geometric series. And just like the previous question, when you know there is a geometric series, you say, what is the first term and what is the common ratio? You see that the first term is that. And the common ratio, this seems to be multiplied by a negative half on this term, and this seems to be multiplied by negative half on that term. And when that is done, we call that the common ratio. And measuring the numerical value of how big the absolute value of the common ratio is, we can tell that this is a geometric series with a small common ratio. And hence we know this series converges. There, this is a converging series.